Thank you for joining in and being part of this evening. This is Pratap Kolla from TCS. On behalf of TCS ION, I welcome you all to this exciting webinar on VLSI Chip Design, Present and Future. Here, once again, I'm thrilled to welcome you all to this power-packed session where we are diving into technology that's reshaping the future of electronics and digital innovation, VLSI Chip Design. In today's technology-driven world, VLSI, which stands for Very Large Scale Integration, that forms the core of devices we use every day, from smartphones to laptops and to medical equipment and to space technology. With the semiconductor industry booming globally and India making bold moves in the space, VLSI has become one of the most critical and rewarding domains for aspiring engineers. To address the growing demand for skilled professionals in this space, IIT Hyderabad, in collaboration with the TCS ION, has launched a highly relevant and practical VLSI chip design certificate program. This program is carefully crafted to equip you with industry-ready knowledge, hands-on tools, and the foundation skills that are needed to step into the chip design and semiconductor world with confidence. Over the next 1 hour, our esteemed speakers, Professor C. Gajendranath Chaudhary and Professor Asudev Datta, the faculties at IIT Hyderabad, and myself will walk you through the current and future scope of VLSI, why it matters more than ever, and how this program can play a pivotal role in shaping your career in core technology. So we are truly excited to have you with us today, sir, Professor Gajendranath and Professor Asudev Datta. As we unfold the journey of VLSI, the present and future, and help our learners discover how they can become part of this fast evolving high impact industry, I just would like to give a brief introduction about both the professors. Professor Gajendranath Chaudhary is an associate professor in the Department of Electrical Engineering at Indian Institute of Technology, Hyderabad, India. His research areas encompass analog and mixed signal circuit design. And about Asudev Datta sir, he is a professor at Indian Institute of Technology, Hyderabad, in the Electrical Engineering Department. His areas of research includes analog and radio frequency IC design. So we have esteemed professors, esteemed speakers with us in next 1 hour. So please be attentive and then listen to them very carefully on this wonderful program on VLSI chip design. So, Sir Gajendranath sir, my first question to you, could you please help students understand what VLSI design is and why it plays such a crucial role in the present and future of electronics and tech innovation?
Sure.
Over to you, Gajendranath sir.
Yeah, thank you.
We have very informed audience of electronics communications here.
Sure. So good evening to all of you. It's very happy to see all of you here. Very exciting. So we'll discuss what actually is VLSI and how it plays a great role in everyone's life. So I want to just give you a brief history. If you go back, a lot of innovations happened during the Second World War, right? All the communication technology, all the electronic amplifiers, all the control theory, all the digital electronics theory has been developed during the Second World War. But however, that theory has not taken into real practical application till the transistor was invented. So what happened? They found a lot of mathematical theory to develop different systems, but they don't have hardware to realize it. So transistor was invented, then slowly they started integrating those transistors onto circuits called integrated circuits. It's not just one transistor, but hundreds of transistors they started putting together. So that's why you see how the entire world, the revolution has come. So initially we used to have a radio, right? I don't know how many of you have seen still the radio. And after the radio, we also had TVs, right? In those days, if it goes back to 80s and 90s, we have only used to have one Doordarshan channel, right? In India, most of us used to watch this. You can ask your parents, they must have gone through this. So, and you see TVs are also bulky and they're all made with cathode ray tubes. Now, later, if you see, our journey has moved to some disconnection where you used to have a lot of channels. Now, really, revolution happened after 70s where more and more transistors were integrated. So initially started with 1000, 2000, 10,000 transistors integration. Now we can see that lots of transistors are integrated. Now, if you see, everybody understands only potato chips, but everybody life runs on two chips. One is potato chips, one is silicon chips, right? So probably if you ask the old people, they don't know what is silicon chips, but if you go to an hospital, right, any machine, whether it's an X-ray, whether it's MRI, whether it's a CT, whether it's a ECG, whether it's a EEG machine, or you get into your car, right? You have so much sophisticated electronics, right? The automatically opening the doors and closing and wind control and electricity and the battery management. There are so many things which are there inside the car. And especially all of you are holding a smartphone in your hand, which is all built based on chip technology, VLSI chip design. I mean, we cannot imagine our life with the cell phones without a chip design. So can we go to the next slide? Yeah, can we go to the next slide, please? Yeah. So all of you know, right? Most of you are 80% are from electronics and communication engineering. You all must have learned this. VLSI stands for very large scale integration because we are trying to put millions and billions of transistors in a single chip. So that is actually what is enabling processors, memories, system on chips, and so on and so forth. As I said, we cannot think of our life, right, without VLSI because VLSI and hardware design is a backbone for the smartphones, laptops, the vehicles, the Internet of Technology, and the communication, the medical equipment. You name it, from the time you get up in the morning till you sleep, without your knowledge, use the silicon chips, which are basically designed using VLSI design. Please go to the next slide. Next slide, please. Yeah. Yeah, just a slide back. I think jump 2 slides, isn't it? Yeah. So why is the VLSI crucial today? Because you name it AI, right? You know, all of you must be using ChatGPT to answer your queries. It's all done with dealing with VLSI design. Imagine there is nothing called ChatGPT without hardware, and there is nothing called hardware without a VLSI design. And another very interesting thing which is going on is in autonomous systems. For example, autonomous driving, which needs huge amount of image processing. The image is taken from the cameras. That also needs the VLSI design. So one of the key challenges in the VLSI design is about you have to miniaturize things. See, old days the computer used to be a building size. Now the computer or the process sitting in your cell phone is at least 1 million times powerful than the room sized computer. The room size or a building size computer has become a small chip which is basically powering your cell phone. So this way, the VLSI plays a critical role uh, in AI 5G. The main reason is you are able to put many transistors, packed transistors onto single chip. And also these chips are not only small, they're also extremely power efficient. For a switching operation, it only takes a few picowatts to nanowatts based on the frequency you're switching. And the capacitances associated with devices are few femtofarads. You must have seen in your electronics laboratory microfarads, nanofarads, picofarads. But inside the chip, if you go, the capacitance order is femtofarads and attofarads. That's why they're very power efficient. And also one of the important need for any country right now is the security. And the security and the electronic warfare all depends on semiconductors. If if company is very strong with semiconductors, VLSI design and making those chips into reality, that country is super secure with respect to all angles. And this is what is actually making the VLSI design extremely important in industry and academia. You will be surprised to know that across the globe, for every 3 designers needed, there is only one VLSI designer available. It means there are 3 jobs needed, 3 people are needed for a job, but there is only one guy available. That means that there is a high demand for the job market as well. Please go to the next slide. Yeah, for example, as I was telling you, how many transistors are there? If you take in your Apple's M3, right? Initial M3 had 25 billion transistors, not 1, 2, or 3. And for your surprise, all those 25 billion transistors work. It's not that one of the transistor fails. I think we are more or less done, right? Your aircraft has 2 engines, one engine fails, another engine comes. But here, we can't add so much redundancy, right? As the time progressed, in the recent M3 processors, we have 92 billion transistors. That's like massive. And each transistor is just a nanometer or 2 or 3 nanometer. So that's how complex this is. That's why it needs, it's important and it needs you to learn a lot of skills. Yeah, I hope that answers your question. So,
Yes, sir. Perfectly, sir. Thanks for giving the introduction about VLSI and how it plays an important role in the national security and in our day-to-day lives. Thanks for the wonderful introduction, sir. So my next question to you, sir, it is how does this program by IIT Hyderabad and TCS ION help students match those industry expectations? Would you please
yeah,
give some
yeah,
light
yeah.
on this, sir?
Correct. So why VLSI matters to you and us right now, and how TCS ION and IIT Hyderabad are helping that? Because as you know that Indian semiconductor mission, the government is putting a lot of money in it because, as I told you, for national security and for our lively, for our uh, increasing the comfort of life for the people, living standards, the this semiconductor plays a crucial role. So we have 20% plus global chip design workforce from India. And there are a lot of opportunities in semiconductors in India. So please go to the next slide. So what do we do in really VLSI design? Yeah. So we basically have an architecture, then we have a RTL, then we have verification, then we have a layout, then we have a tape out. Then we do the fabrication, we do the testing. And all this needs powerful electronic design, EDA tools, right? This itself is a complete ecosystem. Now at IIT Hyderabad, and with the help of the TCS ION, we are launching this course because IIT Hyderabad has produced a lot of analog and digital engineers over the period, and we just don't speak some theory in the classes. We actually design the chips. We do complete architecture, we frame, we do the RTL, we do the electronics, analog IC design, we do RFIC design. We put all of them together, we verify it, we do the layout, and we have sent to the tape out, and we have done successful fabrication of the many integrated circuits, and we tested them. And also, as a part of this course, this next slide, please. We are going to have some, if you're going to come on board here, and we are going to have some practical live lab sessions where you can do simulations, you can do small mini projects, you can have an experience with complex EDA tools, and you can also learn how to work as a team, because you may be building a very small subsystem, but if your cell phone to work, there will be hundreds of subsystems integrated. So you'll also learn how to work as a team. Please go ahead. Next slide. Yeah. So if you come from the IIT Hyderabad, right, as I was telling, we have done multiple tape outs. We actually were also introduced a BTech program in IC design and technology, where from the second year onwards, our students start designing the chips and we fabricate them and they start verifying. And interestingly, IIT Hyderabad is one of the first Indian institute where we had a program called Fabless Chip Incubation, where there are more than 40 to 50 companies incubated, semiconductor companies, design companies incubated at IIT Hyderabad. So we have that ecosystem is also built here. Yeah. Next slide, please. Yeah, this is the way I was talking. We just don't talk a lot of theory. We have designed many tens of chips. These are what you are seeing here is the image micro photograph or micrograph of the chips we have designed here. So they're also published in very reputed journals. So this is how IIT Hyderabad has all the tools needed, all the faculty are experienced is not in just talking the theory, but they have realized the chips, they are tested in the laboratory. So, and also TCS ION has been expert in bringing the skills and putting the things together. And it basically does a good bridge between the students and IITs and NITs to launch many programs. We are very sure that this is going to be very successful program and a lot of you are going to heavily going to benefit out of this program. Yeah, thank you.
Thank you very much, Gajen sir, for giving high-level overview about the program. I will walk through about the program in detail towards the end of the program, sir. But before I go to Asudev sir, I think the audience are very, very interactive and some of them have asked very good questions. So I just wanted to ask, I wanted to put those questions to you, sir, right away. If you can answer those things, it will be really wonderful, sir. So one question is, what is the fabrication process of PMOS? I don't know whether I've read it correctly or not, but that is the question. One of the
PMOS. You are asking about
PMOS.
Yeah.
PMOS.
Okay. PMOS generally, see, not one PMOS. As I told you, if we have 100 billion transistors, 50% of them are PMOSes, right? 50 billion transistors. So each transistor is made in N-well. Inside the N-well, you have a P plus and you have silicon dioxide. On top of it, you'll have a gate. That is a typical CMOS technology. But as the time is progressing, we have FinFET and other. But fundamentally, you have a gate, and there will be a channel, and there will be a drain and source. So the PMOS is typically made inside the N-well. Yes. Yeah. Next question.
Yeah, very good. Okay, sir. And I think related to that, there is one question on what is a big MOS? BICMOS. That's one of the questions that they have asked.
What is that?
Big MOS. BICMOS. Big MOS.
Big mass?
Yeah. Maybe there's a typo.
You mean, okay, you are telling about BiCMOS.
Okay, BiCMOS.
Yeah. Ashu, you want to add something here?
Yeah, whenever you are talking about CMOS, there will be a BJT. Earlier days, people use BJT, bipolar junction transistor. CMOS means it is basically is a voltage you are applying, you are getting some current. Anything when you apply some voltage, you get current or voltage on that. And in the bipolar case, you are applying current and you are getting current. So these transistor level, the difference is same on that, but only the operation level there is a difference is there. One is the current to current, one is the voltage to current. And this BiCMOS technology, earlier CMOS was very not popular. That time only bipolar was there. Then when CMOS came, people have introduced bipolar as well as CMOS together so that you can work very high frequency application, say 100 gigahertz, 200 gigahertz, and you get a very good noise and other performances.
Okay, very good, sir. Okay, sir. So before I move to you, Asudev, sir, many many students have asked one very common question. It is like this, sir, we have zero knowledge on the subject. Will this bootcamp teach us like from scratch to a decent level along with some practical knowledge? That is one question. Another question is, can non-IT people do this course? And another related question is, I'm working as an embedded test engineer and pursuing MTech in embedded systems. Shall I go for this VLSI chip design? Is that useful for me? I need clarification to choose the right path for my career. Can you give me the clarification on this? So I think any one of you, if you can take up this question, then I'll go to specific question to Ashudev sir before I put the questions.
Okay, so first question is that bootcamp, this program, one of the uniqueness is bootcamp. So that what you did in the hands on, basically in the paper you are writing something. But when you're writing in a paper, some circuits or some transistor or something, how you able to show that that's actually really working in a simulation platform, so that you can believe whatever your diagram or whatever the IV equation you are drawing, how it is looks like. One of the things. Secondly, if you integrate them, because two transistor you integrate, it will be a CMOS, NMOS and PMOS. How it will be performed? Not in the only equation maybe give one formulation, but this bootcamp will give multi formulation. Those connectivity, how it will help to get a multiple response. Suppose say transient response. If you know transient means some AC response, some DC response, noise response. So this bootcamp, our idea is to bring you that hands-on to the practical domain, and our researcher as well as we together make you to be skillful in the VLSI chip domain. That is our understanding. And obviously this 1 week course will be extensively behind with you, so that you do a lot of practical example in this bootcamp.
Just one more point to add. There will be not just analog design. We'll also have a digital design where there's an RTL, there's a Verilog, there's a VHDL, and how do you do verification of this? All this also will be taught. It's not just pure analog or RF design. You'll also have a digital design. We also have expert faculty who are going to take up that.
Okay, sir. At the end of this webinar, I will walk through the curriculum module that will be covered to all the learners, sir. So all the learners.
I think one more question was that embedded.
Yes, sir.
Embedded people, if you have a good understanding of the chip design, you will be get a good interest on the embedded on that. So you can change the career path also in that VLSI chip design.
See, one more thing for every embedded engineer, it's better that you understand VLSI design flow also very thoroughly. Even you wanted to continue in the embedded line, this gives you extremely good experience and understanding, because a lot of things you imagine things, you don't need to imagine, you know what it is. And since it's a very quick program, that gives you a lot of idea. It's a power packed program.
Yeah. Thank you, sir. Very good information. So all the learners, please be alert the messages that are coming from the professors. So now I'm going to ask a very specific question to Ashudev sir. Sir, question to you is, many learners often look for jobs in software or IT roles. But with India making big moves in the semiconductor space, what kind of companies are actively hiring in the VLSI sector? Could you give us an idea of the job market demand, the kind of roles available, and even some tentative salary expectations? How is this VLSI program by IIT Hyderabad designed to prepare learners for the real world job market? I think this will answer many of the questions that the learners are putting up, sir. Over to you, Asudep, sir.
So first of all, thank you on that question. So if you look earlier, India actually in 1919 kind of thing, our first semiconductor activity started in a two mode, actually, in the chip design mode, fabrication mode, as well as some circuit design mode on that. And this is single transistor, dual transistor, those things. But gradually MNC has started pumping to the India. And it is a, whenever the IT industry booming, just after that, the VLSI industry also start booming on there. And India government has last 6-7 years has been enormous effort they are giving, so that India can build their, not only support the MNC, also they can build their chip. So you are coming to that arena where you himself can join MNC as well as startup, as well as different foundry, as well as OSAT industry. So these give you a kind of platform for the new people. Is it a IT is the only choice? No, IT is the one choice, but VLSI is the kind of thing Even I tell you, one of the professor called Bram Nauta, even in swimming, he thought that how Nauta OTA can be created. So even you running, playing, or you are doing some activity, you can think how your 2 or 3 transistor or 10 times 100 transistor can change the complete ecosystem. So that's why when the started India in the 1990, then we have 100 of company has been came to India. Even now it is reached to be 200 right now in the VLSI industry. Along MNC as well as around 100 startup has come out, and in the digitally incentive which government is giving, their priority to build the fab, build the packaging and assembly, then build the young engineers or startup to entrepreneur, and massive VLSI job opportunity in India. What happening? Another example I give you, Taiwan, China, and Japan. They are also very, very crunch of the VLSI engineers. They move to one domain to other domain on that. So if you look on not only India, but in the overall globe, there is a huge demand. Right? Today, I think around 2030, I mean, this is a just projection, 50,000 engineering job available in the VLSI, as well as 1 million job globally available in the world, and that India will be take part of that, because the when innovation start, India is the innovation age now. Like all young people thinking how to do new, how to thinking, they are spending time. So VLSI is there creating lot of job opportunity across globe. So I can say industry level. If you can go next slides.
Yeah. Meanwhile, just to add, the one of the advantage of this course is also to bridge the gap. You all have done BTech in ECE, but the VLSI design expects some skill set from you to really take part or to get job into that. This also acts as a good platform for you to get into that career. Yeah, please go ahead, Ashwin. Yeah.
Yes. So I'm telling that if you see, whenever you go, I have an Intel processor, I have an Apple phone, there will be some processor is there. Micron, you have heard that Micron is a big industry has started in the Gujarat. So all of that, more than 100 companies is there, and every year they have an intake of 10 to 12% intake they are increasing, because they feel India is the knowledge hub to create VLSI skill. Secondly, India's, if you look, there is a lot of service industry. Earlier, these industries focused was the IT. Now, every service industry, ACL, Infosys, TCS, all are hiring heavily for the VLSI industries on that, because these people feeling that this India's engineering skill set gradually in the VLSI domain is increasing. So, these our VLSI program, our objective to give you some platform so that you can understand how company and your learning connectivity is there on that. And moreover that, IIT and government organization, there's a lot of project and master position, MTech position. You are coming, you don't know what I'm learning, what are the thing is there. This program with BTech, you are going to the master's position, you get a kind of connectivity. What is the right thing to choose on the field on that? What I'll do finally on that. On that. Please proceed in the next. So what are the job role available? So one is the VLSI design engineers, which is very common, and that, but is it a mass? No, VLSI design engineers is also maybe 10% on that, 10 to 20% on that. Physical designer, ASIC design engineers, these are the two area, and SOC engineers, and then the verification engineers. So digital domain, you have a 70%, and 30% is the analog and code domain. And this 30% also gradually increase because of our startup ecosystem. And typical freshers pay scale typically varies multiple time. Tentative number I'm giving. It's varied to 35 to 70K. But if you really excellent, because this is excellence on that, and company scale of that, depending on company to company vary. Suppose you are joining in TI, that scale will be very, very different. If you joining typically ACL or Infosys, this is the scale of that. And whenever the good thing of that VLSI engineers, as you increase the experience, suppose you are a 3 years experience, or 5 years experience, your salary jumps from heavily, actually, which is very typically software industry still in the three years fellow get a not very big difference on there. Today's domain on that. Because it is a very important, after 2 to 3 years later, people believe he can be really solid engineers on there. Nobody want to leave you. They want even you join from one company to another company, your opportunity is more and big on that. Please go to the next slides. So I think Gaina sir has covered most of the thing on that. So we'll want that students, you are learning, but we want to do the core subject learning understanding by our professors. Then will be bootcamp we are bringing so that analog and digital practical IC design will be tell you, and will be give EDA tool exposure on the state of IC, and will be show how chip has been layer is there. Chip is does not meaning on transistor drawing. Chip has a different layer of that. Okay, like if you see in the books there is a one transistor or one register, but how register is look like in when you design a chip on that. And obviously this is our understanding. Anytime anything you can connect us. Thank you. There any question?
Thank you, sir, Ashadev sir, for giving a bird's eye view about the roles that are available for the learners, the salary packages, and more importantly, what you have said is this package, the salary package is directly or exponentially proportional to the experience, which is unlike in the IT world, but it is very relevant in the chip design and the VLSI and semiconductor industry. Thanks for your wonderful introduction about the domain, sir. Thank you, sir. So I would like to walk through the curriculum or course now because there are a lot of questions on those areas. Then I'll come back to a few questions to both of you, sir.
Thank you.
So allow me to cover the program details for a few minutes. Then I'll come back to the Q&A, sir. Yeah. So all the learners, thanks for patiently listening to this wonderful introduction from Gajen sir and then Ashadev sir. They are the professors from Indian Institute of Technology. So whatever they are telling from their real experience. So I don't think we will be able to get such a wonderful opportunity to hear from those very knowledgeable professors. So let us discuss, let us understand the certificate program. Many of you have asked about, will I get the certificate? Is it free? Is it paid? Is it offline? Is it online? The duration. So all those questions will be answered in this. Please pay attention and be patient. So this is the program, certificate program is VLSI Chip Design, and it is by IIT Hyderabad. Next slide, please. So the duration is 2 months, 8 weeks program. So we are planning to start this from October, so the second week of October till end of November. So which means it is 8 weeks. So this 8 weeks, it is completely online learning. And then we have a 1 week boot camp, 1 week physical hands-on practice sessions at the campus, IIT Hyderabad campus in Hyderabad. So that is the duration and the hands-on part of it. So this is offered by IIT Hyderabad, and TCS ION is the technology partner where you will be paying attention to go through the recorded lectures or to put your questions, the discussion forums to get the clarifications. And professors will also give introduction about the cutting edge tools. Ashadev sir mentioned about EDA tools, so you will get to know about those things. So there will be hands-on sessions, and overall it covers the 45 plus hours of lectures, online lectures, and there will be interactive learning, which is not counted in the number of learning hours, but it can go up to your interest. So offline learning can happen throughout the duration of the course for the entire 2 months. Next slide, please. So this is the beautiful building of electrical engineering department at IIT Hyderabad. So this is where you will be physically visiting and then practicing on EDA tools in the campus. Next slide, please. So this is basically recommended for freshers and the individuals who are pursuing bachelor's or master's degree program and who are aspiring career in the field of VLSI, electronics domain, junior or mid-career professionals looking for accelerated career path. See, some of the questions I have seen where, sir, I'm not from electronics background, I'm from maths background, I'm from IT background. So what I suggest is, so we are going to have a series of masterclass sessions in next few weeks, and those are free. Please attend those sessions, and then you can decide whether to join this program. If you think that this is completely different from your line of career or your line of thoughts, it is up to you. But if you are already from ECE background, electronics background, or planning to move to this particular domain, where Ashudev sir has given a wonderful picture about the career path and opportunity that are available, and then don't miss any of those masterclass sessions. And you are going to develop expertise in these tools, Cadence, LT Space, Mentor Graphics, and these are very popular and very relevant tools in the current times. And these are some of the activities or processes that you will be doing. Design and simulation of test benches, verification of implementation of digital and as Kajan sir and then Ashudev sir has rightly mentioned, this program, this certificate course has two major modules. One is on digital IC design and second is on analog IC design. And at the end, there is a hands-on practice on EDA tools at IIT Hyderabad campus. These first two modules will be covered online. The third will be physical campus immersion boot camp, whatever we call, that is a physical visit at IIT Hyderabad campus. Next slide, please. So these are the outcomes that we thought of that you will be benefited at the end of this program. So you'll be able to use Boolean logic, Boolean algebra, and simulating gates with VHDL and Verilog tools. And you will be able to study sequential logic, flip-flops, FSMs, registers, and combinational logic minimization. If you are familiar with electronics and communication stream, I think these are very much relevant to you. But these are some of the outcomes. I'm not going to read all of them because of the paucity of the time, but you can, because this recording also going to be available to you, so you can go through at any point in time and gain practical experience with amplifiers and learn op-amp architectures and technologies. So these are some of the outcomes, not all, but we have just mentioned very few. Next slide, please. So this is how the entire certificate program is designed. So we have experts who would cover the sessions live, two days in a week. One session will be on a Wednesday, that is a weekday, and another session will be on a Saturday, that is on the weekend. So there will be 2 live sessions in a week, and all those live sessions will be recorded and then will be made available on TCS ION platform. And during the during the live sessions, there will be industry use cases will be discussed, and there will be live doubt clarifying sessions, and there will be offline doubt clarifying sessions will be there, and there will be peer networking through our discussion forums feature available on the ION platform. And there is a dedicated LMS, learning management system, that is available, where you can interact with the faculties, you can take up the quizzes, you can verify your knowledge, and you can give your responses, you can post your queries, get answers, and there will be hands-on learning experiences at the end of the program, towards the end of the program. Next slide, please. So these are the value added. At the end of the certificate, you will get co-branded certificate. On completion of certificate, it will be jointly branded between IIT Hyderabad and TCS. So all the use cases, quizzes, hands-ons will be available to you to enhance your learning. And there will be doubt clarifying sessions by the professors, by the teaching assistants, and by some of the industry experts. And there will be interactions with SMEs, and you will also get job-ready skills towards the end of the certificate program. I'm coming to the cost of it. Please be a little patient. I'll come to that. Next slide, please. So these are the professors who are going to cover the entire certificate program. We have 5 professors. So you have already interacted with Professor Ashudev Datta sir and Professor Gajendra sir. They are from Electrical Engineering Department, IIT Hyderabad. You can see their research areas, and we will have a masterclass session from other professors. Dr. Abhishek Kumar is going to take one masterclass session in coming weeks, and we have Kapil sir coming up in the next few weeks, and Rajesh sir will be taking up our next immediate masterclass that is scheduled on 22nd. I'll give you the details on that. So, so we have these certificates planned. So we have a certificate of participation, certificate of achievement, and certificate of excellence. So we will have a series of quizzes throughout the course, and we will consider the average score with all the quizzes, and those who get 35% or below, they will get a certificate of participation. Those who get 35 to 75%, they will get certificate of achievement, and those who can score above 75, they'll get certificate excellence. These are the 3 certificates we have planned. So these are some of the roles that we have identified. These are some of the roles that are popularly you see on the job portals and which are relevant to the VLSI semiconductor electronics domain. And some of these roles are explained by Ashadev sir also in his orientation. VLSI design engineer, physical design engineer, analog design engineer, ASIC design engineer, layout engineer, verification engineer, test engineer, product engineer. So these are some of the roles that are available which are relevant to the certificate program and which are market demand roles or opportunities as well. Next slide, please. So coming to the key part of the program. So we have hosted the VLSI Chip Design course on the TCS ION platform. I will be sharing a QR code at the end of the course, so you can scan it and then go to the website. And on the website, you can see a buy now option. So when you click on the buy now option, you will you can see more details about the program on the microsite on this website as well. And what is the program duration, the objectives, curriculum, and the professor details, the duration, outcomes of the program, all those things you can see. And at the end, if you want to get benefit from this program, you need to click this buy now button, which will take you to the purchasing options. Next slide, please. So once you click, the system will give you an application form where you need to provide all the relevant details. Once you give that, then goes to the next please. Then you have this options. See, we have 2 buttons, 2 phases of this certificate program. One is VLSI Chip Design, which is 14,160. Then we have a boot camp, which is optional. We made it as an optional, which is for 9,440. So this first thing is completely online, and this is completely physical. This is a practical experience on the tools at IIT Hyderabad. But this we have made it as an optional for this particular cohort, for this particular batch. And you can, if you want, you can buy both, or if you want, you can buy the first one. Those who purchase the first one now and don't want to purchase the second one later, we will provide you a QR code option in the due course, and you can purchase the bootcamp alone during the course. But this first certificate program has to be mandatorily purchased. Only then you will be able to purchase the bootcamp later. But if you decide to purchase both together, you can do so. You can both put together, it will be 23,600, including all taxes. Next slide, please. So if you put together this thing, 23,600, the bootcamp, we made it as optional only for this cohort, and then we will see for the next cohort. So you can uncheck it if you do not want to buy, but you can buy it later at a later point in time. But you have given an option to buy together now. Next slide, please. So this is the final slide where the payment option will be given to you. 14,160 is for online certificate program, and then 23,600 is for the certificate plus bootcamp at IIT Hyderabad. So that's the payment related details. And if you look at the kind of fees that we are charging compared to other certificate programs in the same field, this is very, very, very less compared to other certificate programs. Some of the certificates are being offered at 1 lakh or 1 lakh plus. So the kind of details that you are getting for this price, I think it is very much, what do you say, very useful, and then you will get a lot of details from this program at this cost. So that is about the certificate program. Is there any other slide left after this? Yeah. So that is about the certificate program. Sir, Professor Asudev sir and Gajen sir. So what's your key message for the students who are considering this program? So please share your final thoughts, sir.
So my understanding of that, you have a book, Income Beyond Book, and one of the opportunities, suppose you have given so many exam time on that your process, you want to see what is IIT, because that was the one tag name. Always people think one time I'll be in IIT. And my life on that, I'm telling, come IIT, see that how 24/7 students work and build the chip, and that experience on that life, it will be give you at a different flavor. How will come to in your complete change your mindset and make you to be next journey very successful. Rajendra, please.
Gajen sir, your thoughts?
Yeah. See, this is very important course. As I was telling you, this is like a bridge gap between what industry is looking and what you studied. You studied a lot of theory, but you don't know how to apply and how to look for the jobs in VLSI. As you know that all the EC students, most of them opt for the software jobs. There's a very good opportunity for have a career in that, as explained in the slides. As Professor Ashudev told, when you visit here at IIT, first thing is we teach you online, all the professors. Second thing is when you come to the campus, you'll also see our facilities, especially with respect to VLSI design. You can interact with our master students. We have a BTech program in IC design and technology, and so on and so forth. And trust me, this program is very, very cheap compared to many other programs, as Mr. Pratap was telling. See, you will be surprised that the EDA tools you will be using and you will be learning here is what industry is going to use across the entire globe. Whether you are in China, whether you are in US, whether you're in Europe, anywhere, you are going to use the same tools. Whether you are building advanced 3 nanometer technology SOCs, or you are doing chips in the car, what tools you use, the same tools we are going to use here. They are all industry standard tools and they're very expensive. That's why these courses which are offered outside are also very expensive. So my strong recommendation is join this course. It gives you a big jump to your career and creates you a lot of interest in you pursuing VLSI hardware design jobs. Thank you.
Wonderful, wonderful, sir. Few questions. Is it okay if I ask few questions, sir? There are a few very interesting questions in the chat. So from Dr. Subrata Devnath has asked one question. Is there any scope for research, work from mathematics background people like us?
I can say that when AI started in the process, there is a connectivity is there. But as per IIT Hyderabad concern, the PhD student typically ECE and that other background of that. But industries, after changing platform of that, they are taking also mathematics people in particularly AI domain of chip design level, some of the logical level on that. This is my answer on that. Gajendra, you can add on.
Yeah, see, when you join this course, when you come here, we will not be able to link your skills with VLSI design, but there are certainly a lot of opportunities for the AI to apply in VLSI design. Since you are already an expert in AI, you can come here and learn the VLSI design, and you can look for the opportunities in that field. Yeah.
Good, sir. Good. So one question, another question related to this is: do we learn fabrication of chips, verification, testing for all these for 23K? I think the answer is yes.
He will basically teach you the design, and you can
Yeah.
verify the design using the advanced tools. But the fabrication itself is a long process, right? We get an idea, we design, we do the layout, we send for the fabrication. It comes from 3 to 6 months back. 6 months it takes to come back into our hands to test it. So what we can do when you come here is you can go through the entire flow till tape out. And since we don't have enough time for the chips to send for fabrication and come here, we can show you some of our designs. And if time permits, you can test some of our chips in our laboratories.
Okay, sir. So this is more a design and verification course, and fabrication is a long duration process which can be explained as part of the program.
Yes, sir.
Thank you, sir. So another question, sir. I'm just glancing the. Can you explain the DLI scheme? Not sure what DLI means. One person.
Yeah,
DLI is basically design link incentive, which government is giving to any well educated person, or you can say students or anybody, to start in the VLSI chip design by entrepreneur. And government, based on your proposal, they will be, you can submit. After that, they will be go through multiple round of that, and they will be selected the people or the selected the company. Basically, it is a companies, you have to register as a company, and they will be allow you to give you 50% reimbursement. Suppose you have invested once year, they will be give a 50 lakhs to you to build your chip on that. So this is the design link incentive primarily. So 42 company already awarded DLI scheme. They are doing multiple domain of chip. So as an entrepreneur, this is the important scheme government has put up so that India build their own chip. That was the whole understanding.
Okay, sir. I would like to take up two last questions. One, I think I can answer. That is, how much cost for physical design? So it is around 8,000 rupees plus GST. That is the cost of a physical visit to IIT Hyderabad campus for physical hands-on. And then the last question to you, sir.
I'll add up, sir, one more thing. Here is the
Yes, sir.
misconception maybe. The accommodation and this thing has to be bear by the students.
Yeah.
IT will be provided those facilities.
That is mentioned on the website itself, sir. The cost is only for the lab visit. The accommodation, travel arrangements, boarding needs to be separately managed by the participant. That is mentioned on our website,
Yes.
sir.
Yes.
Another question is there going to be any potential research fellowships that can be given if we complete this course with workshop, with hands-on workshop? So please, any one of you or both of you can answer that. Sir.
Yeah, I can say nothing is closed there. Everything is open. If you really excellent, not only IIT Hyderabad, any IIT, whatever the project position is there, we can directly guide you to apply. And IIT also have a multiple master's program is there, self-sponsor VLSI. Then there is a semiconductor device. Then integrated circuit and packaging. All many program is there. You can take those opportunity to apply. So you'll get it. What is they are going through on there?
Okay, sir.
You can add up.
One more just thing, as Professor Ashwin is telling, we have a lot of openings in our projects itself, which are funded by private companies and government agencies. We ourselves struggle to fill those positions because we don't find the right set of the people. I mean, we just won IIT among 23, and there are many NITs and many professors have a lot of research and development projects for the VLSI design for the Indian DRDO labs and research labs and the startups. But we don't have the engineers. That is also one of the motive for us to promote this program, to create more and more people who comes and we had a very good experience and come closer to what industry is looking. So there will be many opportunities. If you excel in this course, we ourselves have a lot of positions open, which we can absorb as well.
Very good, sir. So thank you, sir. So all the participants of this program, all the audience, I think you have got wonderful details about this certificate program, opportunities in the industry, opportunities in the IIT itself, the kind of projects, how you can contribute to the national security. All those things are covered in this orientation program. And for more details, please visit the website on TCS Ion. Search for VLSI Chip Design. You will get all the courses. The duration of the course is 2 months. You may think that it is short, but it is basic level program and followed by hands-on practice in the campus. And then based on the response, we will see if we can launch any advanced program in the same topics or in the advanced topics as well. We'll get back to you on those things. But let us start this program on VLSI Chip Design with the 2 modules, digital IC design and analog IC design. And the registration is already open. And then please start visiting our website. And then we have our email IDs are published on the website itself. Any questions, please feel free to post your queries and we will get back to you as soon as possible. Any closing remarks, if you have anything, sir, that we will close.
Yeah, so we sincerely thank each one of you for participating here. So I strongly recommend, whether you join or not, you can attend the master class, which gives you more clarity on the program. And the second thing is, you might be having many friends who would like to know about this program. You can also pass this information. That will be very helpful for someone to join and learn more about this course. Thank you.
Thank you.
Thank you so much, sir. Thank you.
Thank you.
Have a nice evening.
Nice.
Have a great day. Thank you, sir.